This old winter air rule quietly solved damp walls long before insulation existed. For centuries, builders in cold climates faced the same enemy we still struggle with today. Damp walls that rot timber, breed mold, and ruin homes from the inside out. They solved it without vapor barriers, without fiberglass, without spray foam, and without mechanical ventilation. The solution was not insulation, it was air control, used deliberately, seasonally, and with restraint. This winter air rule was so common that it was rarely written down, yet it shaped how homes survived harsh winters for hundreds of years. If you study intact 18th and 19th century houses that never suffered chronic damp, you will see this rule quietly at work. Cold air was managed, not blocked, during winter months. Old builders understood something modern construction often ignores. Cold air itself is not the problem. Stagnant air is. During winter, exterior air is cold and dry. When introduced slowly and intentionally, it pulls moisture out of walls, floors, and cavities. Traditional houses were designed to admit small amounts of winter air continuously, not through drafts, but through controlled leakage paths. Chimneys drew air upward. Loose floorboards allowed slow movement. Attic vents remained open year-round. The rule was simple in practice. Never seal a house so tightly that winter air cannot pass through it. Now, this didn't mean folks had to live in a freezing draft, not at all. Thick masonry, plaster, and timber, these materials helped moderate temperature swings, and at the same time, they let vapor escape. The walls were actually meant to breathe outward. You see, moisture from things like cooking, washing, and just people being around would migrate right into the wall assemblies. Then, it was carried away by the slow pull of cold air, making its way upward through the structure. Damp walls were kept at bay by pressure balance, not by layers of insulation. Back before insulation was a thing, it was pressure differentials that did all the work. Warm interior air naturally rises, and as it does, it creates a gentle negative pressure at the lower levels. That negative pressure pulls in just a bit of cold exterior air through the foundations, sills, and lower wall joints. The incoming air would soak up moisture from all those materials and carry it upward, letting it out through roof spaces and chimneys. This constant movement kept condensation from sticking around inside the walls. The main thing to remember was, you never wanted to interrupt this flow during winter. Old builders avoided sealing the bottom while leaving the top open, or sealing the top while leaving moisture trapped below. When houses were retrofitted poorly in later centuries, damp problems exploded. Blocking airflow without providing an escape route turned walls into moisture traps. Lime, wood, and masonry worked together under this rule. Materials mattered. Lime plaster and lime mortar were central to this system. Lime absorbs moisture and releases it slowly. Wood framing expands and contracts without cracking. Brick and stone allow vapor migration. None of these materials were designed to be sealed. When winter air flowed gently through these assemblies, moisture was never allowed to accumulate. This is why old cellars stayed dry despite bare stone walls. Cold air circulation prevented damp stagnation. The winter air rule assumed materials would get wet occasionally but demanded they dry quickly. Drying speed mattered more than waterproofing. You know, every fireplace was basically a ventilation engine. Even when there wasn't an active fire burning, a chimney would create an upward draft, especially in cold weather. Builders really counted on this effect. That's why multiple flues were pretty common, not just for heating up rooms, but for keeping the air moving through the house. Closing up a chimney for the winter was actually considered pretty dangerous, and not just because of smoke. Moisture was a big concern too. So, when later generations came along and started capping chimneys and sealing up flues while adding insulation, well, they ended up killing the air cycle that used to keep the walls dry, without even realizing it. Dampness started to rise, mold followed right behind, and timber, well, it just quietly began to decay. Folks used to crack their windows on purpose, even during cold weather. It's something that's pretty misunderstood nowadays. Historical manuals from the 18th and 19th centuries actually recommended opening upper windows just a bit during winter nights. The goal wasn't comfort, it was all about controlling moisture. Warm, damp air could escape up high, while cold, dry air would come in lower down. That's how they kept things balanced. Heavy curtains and shutters, they actually controlled heat loss while still letting airflow continue. This little practice explains why so many old houses don't have mold problems, even though there's no insulation. The whole system really depended on routine behavior just as much as it did on construction. Now, this knowledge, it's not just nostalgia, it's actually usable. If you're living in an older house, especially one built before 1940, sealing it up tight without redesigning the airflow, well, that'll create damp problems. A real practical application is just maintaining a vertical air path. You should keep at least one chimney vented all year round, and if that chimney isn't being used, just install a passive vent cap instead of sealing it up. Basements, they should never be sealed completely in winter. You want to allow some controlled cold air to enter through vents while making sure there's a way for air to exit upward. This keeps stone and brick dry. Modern dehumidifiers, they kind of mimic this effect with machines, but honestly, winter air does it for free. In living spaces, cracking a window slightly at the top of the house during cold, dry days can reduce interior humidity dramatically. This protects walls, furniture, and structural timber. Heating costs rise slightly, but long-term damage drops sharply. The danger of modern insulation without respecting the rule is real. Adding insulation without airflow consideration breaks the system. When vapor barriers trap moisture inside walls, winter condensation forms at cold surfaces and cannot escape. This is why insulated historic homes often rot from the inside out while appearing sound externally. A safer approach is insulating selectively while preserving drying paths. Insulate floors before walls. Focus on attic insulation while keeping roof ventilation open. Use vapor-open materials like mineral wool rather than foam in older structures. So, here's the thing. This rule, it really mattered for survival, not just comfort. Back in historical households, damp walls meant illness, spoiled food, and, well, sometimes even the whole structure collapsing. Mold wasn't just some aesthetic issue, it was a real survival threat. The winter air rule protected stored grain, dried meat, and wooden tools. Honestly, it even preserved the house itself as a long-term asset. And, this same principle still matters today, especially for preppers and long-term planners. A house that dries itself out without needing electricity, well, it stays livable when all those systems fail. Passive airflow is real resilience. In grid-down conditions, opening up controlled airflow during cold weather can keep moisture from building up from breathing, cooking, and washing. Just a small upper vent, along with a lower intake, keeps things dry. This simple fix reduces respiratory illness and helps preserve your materials too. For cabins and seasonal homes, you should never seal them airtight for winter unless they're fully heated. Always allow some airflow to prevent that freeze-thaw moisture damage. Old trappers, they understood this instinctively, What old builders knew, but, well, never really advertised, they understood that buildings have to dry out faster than they get wet. They trusted air a whole lot more than barriers. They designed houses to work with winter, not fight against it. That winter air rule, it wasn't just a theory, it got tested over generations. Modern building science is slowly rediscovering this truth, but history already proved it long ago. If you found this guide useful and want more deep dives into forgotten survival knowledge, old-world building wisdom, and practical history that still works today, go ahead and subscribe to Warfield Prepper Chronicles. And hey, share this with fellow researchers, preservationists, and preparedness-minded friends who care about understanding how things were done right the first time.